Welcome back, Physical Science. This is the FC3.2 mass relationships and chemical equations. So what we'll be doing here is performing stoichiometric calculations to predict the outcomes of chemical reactions using the correct units and correct number of sig figs. So masses and chemical equations. So the coefficients in a balanced chemical equation give the mole ratio of one chemical to another. So that's what we saw back in FC3.1. These values give the relative amounts of one chemical required to react with another. They can also be used to predict the amount of product expected. So the study of relationships between the amounts of reactants and products is called stoichiometry. Okay. Key steps involved in solving stoichiometry problems involving masses are, so first of all, you have to convert mass to moles, as we'll see, and then apply the mole ratio to go from one substance to another, and then go back from moles to mass. Okay, so you'll see there's basically 3 steps that you need to do there, and we'll look at it through this first example. After completing your calculation, check the number of sig figs, of course, in the final answer, and make sure it agrees with the number of sig figs in the calculation. Also check that your final answer is numerically correct and has the correct units. So we'll take a look at one example here to start off with. So a typical astronaut exhales 8.80 times 10 to the 2 grams, of course, which is 880 grams of carbon dioxide daily. Determine the mass of lithium hydroxide required to react all of that carbon dioxide. So it's basically using lithium hydroxide to suck up all the CO2 that's made in a spacecraft. So we look at the equation here. Now what we were given here, we were given the CO2. So 8.80 times 10 to the 2 G's. So that's where our starting point is. And the question is, how much lithium hydroxide would you need to completely use that up? All right, so that's going to be a stoichiometry relationship because both of these are going to get used up completely. So that's what a stoichiometry relationship is. So first of all, as listed in step 1, convert the given amount to moles. So we're going to convert that to moles. Then step 2, use the mole ratio to go from moles of carbon dioxide to moles of lithium hydroxide. Okay, and then lastly, convert moles to grams of the required substance. So those are the 3 steps that we are going to require here. Okay, so of course, to go from grams to moles, we're going to have to find out the molar mass. So we're going to have to find out the molar mass of CO2, grams to moles, and then over here we're going to have to go from moles to grams. So guess what? We'll need the molar mass of lithium hydroxide as well. All right, so if we look over here, so for the molar mass here of CO2, for every 1 mole of CO2, we have 1 mole of C, 2 moles of O, and of course C is 12.01, oxygen is 16, so 12.01 plus 32 gives us 44.01 grams per mole. And looking at lithium, so the molar mass of lithium hydroxide, for every 1 mole of lithium hydroxide, we have 1 mole of lithium, 1 mole of oxygen, and 1 mole of hydrogen. Lithium 6.94 according to the periodic table, oxygen 16, and hydrogen 1.01. So when we add those all up, we get 23.95 grams per mole. So good. So now that we have those molar masses, we can set up our 3-step process here to determine how much lithium hydroxide we need. Okay, we can turn to the flip side there because there's a little more room. So starting off with what we had here, so we had 8.80 times 10 to the 2 grams of carbon dioxide. And of course, the first step, if I just go back to the paper we had there, grams of carbon dioxide to moles of carbon dioxide. So grams of carbon dioxide to moles of carbon dioxide. And of course, to go from grams to moles, we're going to be using the molar mass here, 44.01 grams per every 1 mole. So if we were to stop the question right there, we would be here. We'd have moles of carbon dioxide. But of course, we need to go from moles of carbon dioxide to moles of lithium hydroxide. And it's a 1:2 ratio. So 1 mole of CO2 to 2 moles of lithium hydroxide. So you can see here, so we have a molar mass conversion. And here we have a mole ratio conversion. So that's what we're doing there. Moles of carbon dioxide cancel. If I was to stop the question, I would now be right here. So I know how many moles of lithium hydroxide I have now. So now I need to change that into grams by using the molar mass of 23.95. So 1 mole of lithium hydroxide is 23.95 grams of lithium hydroxide. So I've gone through my 3 steps: moles of carbon dioxide, moles of lithium hydroxide, grams of lithium hydroxide. So over here again, we could write down, it's another molar mass conversion. So the answer, when I multiply that all out, I think I get 957.7823 grams. And if I look over here, there's, let's see, 1, 2, 3 sig figs. 1, 2, 3 sig figs. This is a 7. So that's going to get bumped up. 958 grams of lithium hydroxide. All right, so that's how you do it. That's how you do that. It's a 3-step process. Now, common mistakes, people often look at the balanced equation and they see this 2 over here and they somehow think that that 2 is going to go over here. Well, no, that the 2 and the 1 are just in the mole ratio. The molar mass conversion is always grams per 1 mole. Molar mass conversion, grams per 1 mole. Because that is what you're figuring out here, grams per mole, grams per mole. So on the end parts, you will always have 1 mole and 1 mole. And the mole ratio will always be in the middle. And it uses what is stated in the balanced chemical equation. All right? So why don't you try to do this next one? Maybe pause the video, try to do this one, and see what you come up with. So maybe to get you, oh, actually, I think this one, I forgot to put the question in here. So we'll have to write out the question here. So it says an automobile airbag is inflated with nitrogen produced from the decomposition of sodium azide. So we have that. But hey, you need a question here, right? So let's write it out. The mass of nitrogen in a fully inflated airbag is 87.5 grams. What mass of sodium azide is required to produce this mass of nitrogen? Okay, so let's get that question down. So the mass of nitrogen in a fully inflated airbag is 87.5. So actually we're given this time. We're given one of the products. Okay, and what mass of sodium azide is required to do this? So you can see here it's going to be working backwards, which is fine. So we're going to, first step, of course, change to moles. And I usually put grams on the bottom, moles on the top, make it easier. It's almost like getting on a bus, going to the back of the bus or front of the bus and getting off. So we're going to use, then right for that middle step, is going to be a 3:2 ratio. And then lastly, go from moles back to grams. So maybe pause the video and see if you can do that. So use the previous one for formatting, and you should be able to do well. All right, so try that, and I'll see you again in the next video.